Let us start.
Hello.
Hello.
Yes, hi.
Let us start. Let us start. Okay, let's go to structure question. Those that I have not done with you can go, you can try out yourself. Don't know, can ask me. Okay, number one, give the definition for focal length, memory work. Yep. Can?
I can't remember, sir.
You are a terrible student. Didn't do homework. Focal length, the distance from the pole of the mirror to the focal point where the ray converge after reflection from a concave mirror or diverge from after reflection from a convex mirror. Then radius of curvature, write down. Radius of curvature is the radius of a sphere to which the mirror is part of. Write down the equation which relate F and R. How is F and R related? You need to do something, Srini. If not, as I said to you, you won't improve your grade. So far, you're the one not doing homework. I'm the one doing all the work. It won't help you. You want to improve your grade, you have to do your homework. That's your part of your learning process. You reinforce what I teach you by doing homework. Yeah, how's the relationship? We have just done so many problems with you already. If you still don't know, I don't know how to help you already. This is your STPM work also. Yeah, that's all. F equals to R over 2 or half R. Okay, copy whatever you want to copy.
Yeah, copy ready.
Okay. A graph of 1 over V against 1 over U for concave mirror is as shown. Calculate the, okay. What is the focal length? What's the radius of curvature? What's the value of P? Yeah, work it out. If you haven't, go and work it out now. Start with the length formula. Right, in terms of y equals to mx plus c. Your y is 1 over v. Your x is 1 over u. Yeah, start with your length formula. That one. Then rewrite that. Okay. So what's the focal length? Yep. Why take so long? It's just a better of maths only. Understand the equation, understand the graph. Then should be able to get me the answer. I've given you more or less the answer already.
Oh,
That's your y. That's your x. This is your c. Oh,
Yeah,
that's a P here.
negative 0, wait, yeah, negative 0.5 plus 1 over f equals to 1 over v.
What are you doing? I want the answer for focal length. Right? Use that as your point. This one equals to 0.
Oh,
Yeah, that's a 0.
so the answer is 2.
Yeah. So if that is
The
0,
answer is 2. The answer is 2.
that's 0, then you have got 1 over f equals to 1 over u. 1 over u is that one there? Answer is 2. What's the radius of curvature?
4.
Double it. Right? Make sure after class have a short nap there. Don't come to class so sleepy. How are you going to concentrate? Value of P?
Value of p, okay, negative.
Yeah, from the equation, that's all. The equation. That's your P. Just that's all. What's the problem? Yeah. 1 over f is your P. 1 over f is that. What answer already? Okay.
Okay.
Didn't study, that's why I say you are going to have a problem like that. Anyway, you can try number 2. Let's try number 3 now. Explain what is meant by focal length of a diverging lens. Can remember? Yeah. Focal length of a diverging mirror, diverging lens. You need to review your class. Review, if not, you are going to be in trouble. All these things must be in your head. Don't leave it to last minute. Is the distance from the optical center to the focal point where the rays appear to diverge from after passing through the lens. That's all. You're not going to draw the diagram. Okay, the diagram shows a diverging lens. Write down the equation to determine the focal length of the lens in terms of the quantity shown. Okay, what's the formula? Go and look into your book. If you don't have, make sure your book is here. Don't come to class without preparation. Book must be there. Paper must be there. Pencil and pen, calculator, all must be ready. Yeah. What's the formula? Go to the lens maker's formula. That's a formula. These are different radius. That's how they have to calculate the focal length. So that's a formula. And then they want you in terms of that. Okay, 1 over f. N2 minus N1. N2 is your N. 1 over R1. 1 over R1. One of them is 20. Both sides 20. Right? Both sides 20. So that's why we get, I put it in terms of R. Both of them are the same, R. R. This is 2 over R. 2 over R. That's all. There's the equation. Everyone, you can replace the R with 20 cm. Determine the focal length in the air. Okay, put in your value, 1.5. 1.5 minus 1, then this is your 2. That one is 20. Calculate out. That's your focal length. Can?
Can.
Okay, copy whatever in the copy. Okay, have you copy or make a note of what?
Yeah.
Okay. Determine the focal length if immersed in a field of density of a reflective index 1.2. Yeah. What's the focal length? Right. Go to the lens formula. Same thing. Do again. Except now your N1 is normal 1. N1 is 1.2. Put to the formula. Okay. 1.5 is this one. And 1.2 is outside. And then we put minus 20 because it's this one looks like concave. This one is also concave. Okay. Can? The others are your maths problem already. Calculate out. Anything not clear? Need more time?
No, okay, can continue, Chair.
Okay, let's try number 4. A fish is 4 cm beneath the surface of a pond. An insect is flying directly overhead. If the insect is exactly 15 cm above the surface, how far above does the insect appear to the fish? Let's give you some idea. Construction. So what should I do? How do I start? Think of the formula to use. Right? You want the lens maker's formula again? Yeah. There. Two different medium. Okay, now to decide after you've got the right formula, now to decide what's your N1. That's your N1. Right? Gravity index of water 1.33. N2 is air. Sorry, you are looking it from inside here. So the ray is coming from here. N1 is outside the air. N2 is the water. Okay, so you want to find V. Right? Your radius, right? That one. As long as the straight line is infinity. And then U is 15 cm. Is here 15 cm from the surface. I can roughly remember I was stuck when I was your age doing this question. From the equation, 15, this is N1 is 1, 1.33 is 1.33 is our V, N2 is 1.33 minus 1, R is infinity, so doesn't have to worry about this term anymore. This one will be 0. Okay, so then instead of plus, it just becomes equal now. And cross multiply, get the answer. Can? Any question? Anything not clear?
So far, okay.
Okay, well, okay, let's carry on. Okay. The figure shows a plastic hemisphere with radius of curvature 10 cm and reflective index 1.66, sealed to the end of a cylindrical rod of same length, same material, sorry. Okay, you draw for your diagram. That's the object. An object is placed 45 cm, that's the object distance, away from C, that's your C, center of curvature, center C of the plastic sphere. That one is your plastic sphere. That's your hemisphere. That's a plastic sphere. That's a cylindrical rod. Calculate the distance of the image formed from the center C. Okay, what formula to use? Okay, should be roughly able to construct. Right? There's your normal coming out. There's your surface there. So instead of it going straight through, there's your surface there. It will be reflected towards the normal. That's the normal. That's all. That's how it go. How you construct the diagram. Can what formula to use? Yeah, that formula. Okay, then form your equation. Your U is 45 minus 10. I've done something wrong. N1 is outside here. N2 is 1.66. That's N2. U. Okay, U is from here. From here, not from the center. From here. That's why I subtract 10 and put in the formula. Right. N1 is 1. U is 35. N2 is 1.66. V is what we don't know. That is your V from here. And N2 minus N1, N2 minus N1. R area total is 10 cm. I use cm. Yeah, my answer will be in cm. I get 44.4 cm. Okay, I think the book made a careless mistake. Right, they put that as 45 rather than 35, because you should measure your U from the pole here, not from the center here. Yep. Anything not clear?
So far, clear.
Copy what you want to copy? Okay, need more time?
No, sure.
Okay, we don't need more time. We can carry on to the next question then. Two essay question. This one. An object is placed 28 cm. Have a rough picture or draw a rough picture. 28 cm in front of the converging lens with focal length. Then sketch the ray diagram of the object. Okay, so 28 cm. Use 28 cm. That's the object. Okay, roughly like where they ask to sketch, that's 7. That's 14. 14 double. 28 double that. Place that object. Then sketch. Yep, parallel to this axis. And after that, pass to the principal focus or focal point. Sorry, I don't know why it's out, slightly out. So it should be here. Okay, that's all. 2 marks. Your SPM work. Any comment? Then calculate the image distance. What is the answer? Go and calculate if you haven't done yet. Yep, what's the answer? Use the lens formula. That's all. All right. Your focal length there. Object distance 28. Take this one across there. And calculate out. Okay, how to find the magnification? Yep.
What's the what, sir?
To calculate the magnification, part 3.
Oh, V over U.
So what's the answer?
9.42 divides 7.05.
Okay.
Not 7.05, sir.
Object distance, not focal length.
Oh.
Okay or not? You correct
Yeah.
formula V over U. V
Yeah,
is 9,
correct.
U is 28. State the characteristic of the image. Yep. 1 mark. Just to state only. Yeah. You should be able to tell me everything done for you already. Draw for you the diagram. Yeah, smaller. Inverted. It's real. Inverted and diminished. That's all. 1 mark. Okay. Copy whatever you copy. Then we go to the next question. Next part. B. Mirror. 8 cm tall object is placed 12 cm in front of a convex mirror. Have a picture how a convex mirror look like with a radius of curvature 32 cm. Convex, then the radius of curvature must be a negative sign there. Calculate the position of the image. Okay. Calculate for me. Use the lens formula. Tell me the answer. If you're asked to sketch, then that is how you should sketch. But they didn't ask you. So how is the position of the image? What is your answer for V? Right, first calculate your focal length from the radius of curvature. Radius of 32. So half of that is 16. Now put a negative sign there because it's a convex lens. Then use the lens formula. Put in your value. Take 1 over u across there. So minus 16. Minus 16. Then this is 12 cm. Across there minus 12 cm. Then calculate use your calculator. Calculate your V. Height of the image. So what's the height of the image?
V over U also, sir.
So what's the answer? Calculate out, and give me the answer.
Zero 0.43.
How do you get wrong answer again?
Oh, I divide by 16, not 12.
Your U is 12.
Hey, not 16, sir.
16 is the focal length. You always use the wrong thing. You don't want the focal length. Magnification is V over U. That's your V. That's your U. Why you put a negative sign, go ahead, but it doesn't matter as long as you know. And the height is height of image equals to m times height of object. And put in your value. That's your 8. So it's 4.75. Okay. Any comment? Anything not clear? Anything not clear? Srini, you need to do something about your life. If not, you are not going to make it. Okay, copy whatever you copy. Need more time?
No.
Okay, then we carry
That's
on.
all right, sir.
Part C.
Last
This,
question, sir.
our time
This
up
is the
already.
last question.
Okay, let's finish the last part C. A dish with diameter 5 cm hangs from the ceiling. Right? I didn't draw the ceiling, but you want can look into your book, the answer there. I'll roughly show you the length there. The distance between the dish and the wall is 300 cm, and the thin lens is placed so that an image is formed on the wall. It's half the size of the dish. State the type of lens used. Yep, what's the type of lens? That's your distance. There's your wall. That's your dish. That distance is 300 cm. Thin lens is placed so that the image formed on the wall is half the size of the dish. Yep. There's a dish. It has to be a converging lens. It cannot be a concave lens. That you must be able to deduce. Right? That's your object. That's your image. Right? You want to be real. You want the image to be on the wall. It must be, to be real, it must be a converging lens or convex lens. Okay. Since the image is real, the lens is a converging lens. Determine the position of lens from the wall. Right? U plus V is given you 300. Magnification is 0.5. 0.5. So your magnification is 0.5 is V over U. So you take U across there, you get that. And put into your lens formula. Put into this formula. Right? Replace a V with that, then calculate your U. So now your U from here, then can calculate your V from this equation. And put in your distance of lens from the wall is 100 cm. Okay. Yep. Can? My picture is a bit poor already. It should be, let me just redraw that. It should be something like that. Okay or not? You're tired? You call it a day?
Yes,
Okay.
sir.
Tomorrow we do a new topic. You can try the rest of the question yourself. So now you can ask me. Any more questions? If not, we will stop here.
No, so far, no questions. Sir.
Okay, if
Okay,
not,
thank you, sir.
tomorrow?
Sir. Hello?
Yep.
Sir, tomorrow can I have it early morning, sir?
No, 9 o'clock.